So thank you for the introduction. And this is Isa from Turkey. As he said, I have been a couple of times in Almaty. The last one was before pandemic, which is like ages before. So it's good to be here again and see you guys here and nice Almaty. I am the sales director for Parallel Wireless, which is an American company. I will make a short intro about the company soon, what we are doing, what we are aiming to achieve, and how to help the telco operators in our region. And I will be mainly talking about how to make radio access networks more efficient. As you know, radio access networks are the foundation and the enabler of all these new technologies that we have been talking since the morning. So, but on the other hand, radio access networks are the most costly items for operators, most painful part of the network in their investments and operations. Okay. So first I will go over Parallel Wireless, a short intro for those who don't have any idea about us. Then a short intro about Open RAN, to make it clear what is the difference between Open RAN and existing legacy architecture, and then how we are contributing to make the radio networks more efficient in terms of power consumption, network utilization. So you can interrupt me anytime if you will have any questions. Parallel Wireless, founded in 2012 in Nashua. The HQ, our headquarters is in Nashua, and we have global offices around the world in UK, in Israel, in India, and we are about 600 people helping and working for the company. And we have been the pioneer of Open RAN movement and providing solutions for all Gs, 2G, 3G, 4G, and 5G, based on Open RAN standards and technology. And we have also quite strong customer engagements from all around the world, Tier 1, Tier 2, where you can see some examples in this map, like in Western, Eastern, and Middle East. And personally, I am also driving an all-G project with Türk Telekom in Turkey currently. So, what is Open RAN? You know, around 10 years ago, there were some companies emerged talking about decoupling hardware and software in the packet core domain. And big vendors or incumbent vendors, without mentioning the name as you know who they are, they were saying it's impossible. And they were providing monolithic-based packet core solutions. Then, at the end of the day, they had to accept that, and they had to provide solutions with the cost-based hardware for the packet core, with the help of those innovative companies like FM Networks that I worked before, which was acquired by Microsoft. So now it's time for the radio network to decouple the hardware from software, to disrupt the vendor lock-in and proprietary hardware and software in the radio access network. So we are in that journey right now. So this is traditional RAN architecture. As you see, all the interfaces between baseband, radio unit are proprietary. When you want to buy a base station from a vendor, you have to buy all hardware, each and every hardware from the same vendor, excluding antennas. So what it means, you are, let me give you an example. You are the owner of the radio units here, let's say. The hardware is owned by you, you paid for it. But if you want to swap, make a swap in the future, replace vendor X with vendor Y, you have to remove all the hardware from the field and go to the field again and install from scratch with the new vendor. This is the traditional RAN architecture. But in Open RAN, this is not the case anymore. Because all the interfaces between radio unit and baseband are becoming standard-based. So let's say today, if you deploy Open RAN-based base station with vendor X, and tomorrow you might not be happy, the only thing you need to do is remove the software of that vendor and install the your new partner software and having the site up and running. You don't need to go and remove the hardware from the site and do the site work from scratch. So what will be the advantage of Open RAN? What are the promising points of Open RAN? Of course, by avoiding vendor lock-in, you will have more competition, more innovation, and at the end of the day, of course, better TCO and ROI. So as an operator, as Murat Bey was also mentioning, today we have operators are facing declining ARPUs, but increasing costs for their daily network operation in terms of both CapEx and OpEx. So tough times for all of us, for vendors, for operators. So there should be some innovations, especially on the radio access network side, because of those simple reasons. The radio access network is roughly constituting 73% of the power consumption of the whole MNO's network. This is a huge number. So also the radios are 50% of the energy consumption. Another interesting figure is 1.5% of the world energy consumption is coming from the MNOs. And also as the existing network architecture is site-based architecture, the overall network utilization compared how much it is utilized versus how much money is spent is significantly lower. And of course, because of these reasons, RAN is creating the highest CapEx and OpEx for an operator in their investments. And this must be changed. So as parallel wireless, we are stating that we are working on solutions, hardware and software solutions, that is targeting to reach minimum 50% power consumption reduction within 24 months, which is like a huge number, but realistic with the Open RAN-based solutions. So that means it will also cut by half all your site material spendings like battery backup, solar diesel consumption, etc. So what we are doing for this, we are developing power-saving software features. Of course, the incumbent vendors and everyone in this game has some kind of power-saving features, but we are coupling it with the changing the architecture as well. So energy efficient CPU utilization, layer switching off, MIMO switching off, based on by using some AI and ML tools, we are monitoring the traffic and then taking measurement to decrease the power consumption of the sites. Also, we are promoting centralized RAN architecture where you don't need to put your baseband at the site. If you have a good fiber connection between the site and data center, you can easily remove the baseband from the site, put it in the data center, and then your site will be only like a mechanical site having antennas and radio units. But here again, you can hear this story from other vendors as well, because everyone has solutions similar to this. But our difference is, or our innovation is, it is not like one-to-one mapping, removing one baseband from the site, putting it into the data center, and multiplying it by a number of the sites. It is not the case for us. We will have a high-capacity baseband machine in the data center, serving a cluster, managing the cluster, and having redundancy as well. So let's say if that baseband will fail, that centralized baseband, you will have the redundancy for no customer impact and complaint. So by having cluster-based management, you will be able to more efficiently manage the resources of your radio access network in terms of compute resources, spectral efficiency, network performance, and flexibility. Because, as I said, one brain is managing a cluster, not each site individually. So, as a conclusion remarks, Again, RAN, radio access network, is the largest cost item and most painful item for mobile operators, which we believe with the existing architecture or existing approach, proprietary-based approach, it is not possible to tackle and improve. So with the Open RAN-based technologies, it will be possible to dramatically decrease the power consumptions, make the networks more efficient, and it will positively impact mobile operators from cost point of view to the operations and efficiency. Any questions? You have a question?
Yes, there is. So you told us that you have some power efficiency tricks in your base stations. So do they somehow influence the latency? Because we experienced in our course of development of some products, when you switch the CPU of some equipment to a certain state which has a lower power consumption, so returning from lower power consumption to more higher power consumption leads to increased latency. How do you tackle with this?
We haven't faced this, at least from our engineering MPLM. I haven't received such a feedback. But of course, as a sales guy, I need to go back and ask them and see if we have such a concern, or if we will have in our new developed features in the near term. But what we tested is in the centralizer, and this is an interesting figure, on LTE, we tested the fiber distance between radio link and baseband over 40 kilometers, and we didn't face any KPI degradation or latency problem.
So, do you consider using machine learning to do this power efficiency is much better?
Yeah, because you have to use some smart methodologies or tools, because you have to monitor the traffic, make some predictions, and based on those predictions, which must be accurate, you do these power-saving tricks, MIMO layer, switch off, switch on, when to do this, what's the right time, what's the right location. These kind of things require AI and ML tools.
And it will be still working for the base station with the dynamic tilt, regulations.
You mean for the antenna?
Yeah, for the antenna.
Yeah, it might be. I mean, yeah, because antenna tilting is still possible to do it remotely.
Yeah.
It might be.
So guys, any more questions? У кого-нибудь есть вопросы? So,
thank you very much.
Applauses for the Isa Haджiоглу. It was quite interesting. Okay.